Hi guys, welcome back to the topic of trigonometry. In the previous video we saw how important trigonometry is and how many uses it has in our daily lives. We also understood a little bit about trigonometric ratios. In this video we'll see what exactly are trigonometric ratios and which all ratios do we use. In the previous video we saw that if there's a right angle triangle, say the hypotenuse measures A, this side measures B and this side measures C, then the ratio of their sides, say B by A or B by C or A by C or anything, or even their inverses, they only depend on the angle that exists in the right angle triangle. So if this angle is theta, then these ratios of different sides, they only depend on this value of theta and they remain constant for a particular value of theta. So for 30 degrees, if B by A is 1 by 2, then it will remain 1 by 2 for any triangle where theta is 30 degrees. Now you might have heard of terms like perpendicular and base being loosely used to define these trigonometric ratios. Now let's see what those perpendicular and bases are. So the definition of perpendicular and base only depends on what angle you choose. Let this be the right angle triangle, say ABC. We know that in a right angle triangle, the longest side is always the hypotenuse. So there's always a confusion which one is the perpendicular and which one is the base. Is AB the perpendicular or is AB the base? We never know. So if we look at the triangle from the perspective of angle C, then the perpendicular and base would be different, and if we look at the triangle from the perspective of angle A, the perpendicular and base changes. So let's see what exactly are perpendicular and bases. So CB is the adjacent side for angle C. This one is the adjacent side. And AB is the side opposite to angle C. Now the side opposite to the angle in consideration is always known as the perpendicular, while the side which is adjacent is the base. You can see that this line forms the base for angle C. Hence it can be easily remembered that the base is always a part of the angle while the opposite side is the perpendicular. In the same triangle, if we look at it from the perspective of angle A, this angle, then the hypotenuse remains the same, it doesn't change. Now here the opposite side is this and this is the adjacent side. Now the adjacent side forms the base for this triangle, hence AB is the base here, while the opposite side here is a perpendicular. Now for our ease, I'll denote hypotenuse by H, perpendicular by P and the base by B. Always remember, perpendicular is the opposite side and the base is the adjacent side. Also, the concept to remember is that the ratios that we'll talk about, the trigonometric ratios, are always related to an angle and they have no meaning if the angle is not specified, which is why we understood the perpendicular and the base depending on what angle we are talking about. Now let's see what are the trigonometric ratios in store for us. So if this is the right angle triangle, right angled at B, let us consider trigonometric ratios for angle A right now. So when we are considering angle A, we know that BC is nothing but the opposite side and it will be the perpendicular, while AB is the base, it's the part of the angle. and AC would be the hypotenuse as always. So the first ratio is sine of angle A. Now this is the first and the most important ratio. If you remember this, you'll remember all the other ratios. So sine of angle A is equal to perpendicular by hypotenuse, which is nothing but BC, the perpendicular, upon hypotenuse AC. Now the next ratio is cosine. So cosine of angle A is equal to base by hypotenuse. Now it's easy to remember because sine was perpendicular by hypotenuse, so base was the only one left alone. So the next one is cosine, and we have base in the numerator and hypotenuse in the denominator. So the base for angle A is AB and the hypotenuse is AC. Now the third ratio is tangent of angle A. Now we have paired perpendicular with hypotenuse. We've also paired base with hypotenuse. Now the only thing remaining is perpendicular by base. So tangent of angle A is nothing but sine of angle A by cosine of angle A. Now this becomes perpendicular by hypotenuse whole upon base by hypotenuse. Here we see that hypotenuse gets cancelled and we are left with perpendicular by base. And in our triangle ABC, tangent of angle A would be the opposite side, that is BC, upon the adjacent side, that is AB. Now if you remember these three trigonometric ratios, the other three trigonometric ratios are nothing but the inverse of these. So inverse of sine is cosecant of angle A. So that is equal to 1 by sine of angle A. That means hypotenuse by perpendicular. So cosecant of angle A is equal to hypotenuse by perpendicular, which is equal to AC by BC. The inverse of cosine is secant. So secant of angle A is 1 by cosine of angle A, and that would become hypotenuse by base. So that is hypotenuse by base and is nothing but AC by AB. And the third one is inverse of tangent of angle A, and it is called cotangent of angle A, and it becomes cosine of angle A by sine of angle A, or base by perpendicular, which is equal to AB by BC. Now we'll just do a quick recap of what we've just seen. Now we'll see it for angle C. So if this is A, B, C, right angle at B, now we'll talk about angle C. This is always the hypotenuse. Which one is the opposite side to angle C? AB. So this would be the perpendicular, correct? And the adjacent side would be BC, and it's the base. The first ratio, if you remember, was sine of angle C. It can also be written in short as sine C, and it's equal to perpendicular by hypotenuse, or AB by AC. The next ratio is cosine of angle C, also written as cos C. This was equal to base by hypotenuse, which is equal to BC by AC for triangle ABC. Remember what was the next ratio? Yes, tangent of angle C can be written as tan C and is equal to perpendicular by base, which is AB by BC. The fourth one was inverse of sine, that was cosecant of angle C, can be written as cosec C, which is equal to inverse of sine would be hypotenuse by perpendicular, which is also equal to AC by AB. The fifth ratio was secant of angle C. This can be written as sec C, which was equal to inverse of cosine C, that is hypotenuse by base, which is further equal to AC by BC. And the last one was cotangent of angle C, that is equal to cot C and is equal to base by perpendicular, or BC by AB. Now I can give you a trick to remember these. Let's write sine of angle A, cos of angle A, and tan of angle A. Remember, sine was perpendicular by hypotenuse, cos was base by hypotenuse, and tan was perpendicular by base. Now there's a small trick. We'll write Pandit Badri Prasad har har bole sona chandi tole. So this is the trick. Pandit Badri Prasad har har bole sona chandi tole. If you remember this, then you will be able to remember all these ratios. And you know the other three are just inverse of these. So how to apply this trick? Here Pandit Badri Prasad in the numerators. In the denominator we have Hari Hari Bole and Sona Chandi Tole. I hope this helps you remember the ratios. It's always good if you remember the ratios without this, but initially I think you might need to use this. Now there's a small word of caution. We have seen a lot of people use only sine. That does not make any sense. It always has to be accompanied by an angle, sine A or sine theta. Sine alone does not have any meaning at all. Also, it's good to note that these ratios do not have any units, because these are just the ratios of two sides of a triangle. Also, we use sine square A when we have to write sine A whole square. This is just for convenience, but this does not mean that sine inverse A is equal to sine A to the power minus 1. This is not true at all. Never do this mistake. Sine inverse is another function which we'll study later on, while sine A whole inverse is nothing but 1 by sine A. And what is 1 by sine A? Yes, cosec A. We'll talk about these ratios in the next video. Bye.